Maestro. No. What you know about rolling down in the deep?
All right, here we go. Exciting times. We're switching gears to annuities. This is your second last lesson, and this is actually exciting for me because it's my last recorded lesson of the Quadmaster. So, yay me. Our learning goals recognize what an annuity is and use the annuity formula to solve problems. An annuity is a sum of money that is paid as a series of regular payments on investments or loans. Ordinary simple annuities have the payment period match the compounding period, and all payments are paid at the end of each period as opposed to the beginning. Most RRSPs are like this. In fact, most things where you have to make a monthly payment or a regular payment on something is an annuity, like a car payment, a mortgage, talking about investments, RSPs. I mean, people, more often than not, people can afford to make monthly payments or regular payments, as opposed to previous lessons when we looked at you got $5,000 lump sum to invest, or you got 10,000. Most people don't have that money kicking around, but instead they have like, okay, well, I could afford 25 bucks a month, or I could afford 50 bucks a month, or my car payment, I can afford 400 bucks a month. My mortgage, between myself and my significant other, I can afford whatever, 1,200 bucks a month, something like that. This is normally how things behave, not necessarily the way, which was kind of simplified, where simple interest and just normal future value of a normal compound interest question. This formula is a bit more complicated, but you do get to see it. You get to have it as a reference. You don't have to memorize it, just how to use it. So here is our formula. A equals PMT. This is all one thing. Sometimes you might see it as R. 1 plus R over C to the CT minus 1 all over R over C. And that's all in brackets. Whoa. That's pretty crazy looking, right? It's just calculator work, and you just got to make sure you're organized on your calculator. All those letters, we know what they are. A, future value, final amount. The number 1. R, the small r, interest rate. C, compound period. T, time. The only thing that's new is this PMT, or R value, which that just stands for. So again, PMT is not 3 separate letters or 3 separate variables. It just stands for the regular payment or deposit. Again, you could put a capital R there, or you could put a PMT. I like to put PMT there just to remind me that it's a payment and not a capital R, and gets sometimes confused with the interest rate. There's your formula. Add it to your formula sheet. We are about to go into some questions right away. First one, to save money, you invest 200 bucks a month in an account that pays 4.5% interest compounded monthly. Again, highlighting things. Compounded monthly, there's our C. If you did this for 10 years, how much would you end up with, and how much interest did you make? How you differentiate this from a normal compound interest question without using the complicated formula? You're going to see something in there like makes a monthly payment, invest this much per month, or bi-weekly, or semi-annually, or weekly, or daily. You're going to see something where either you're paying into something on a regular interval, and we have that. To save money, you invest 200 bucks a month. As soon as you see like you're not investing a lump sum, but you're investing a rate, an amount of money per interval of time, in this case month, you got to go to it. Your mind has to go to the annuity formula. Now the next lesson, which was recorded, I think, a couple years ago, that's present value annuities. How you know to use future value annuities is it's like how much did you end up with at the end of 10 years as opposed to how much do you need now. So let's get into it. A, that's what I'm looking for. My payment right there, PMT, $200. 1 plus my interest rate right there. Don't forget, convert it to a decimal, 0.045 over C. Monthly, there's my C value, 12. Now I'm gonna skip a step here. C times T. Okay, so maybe I'll make a little note here. C times T just to show you. 12 times 10 years. 120. 120 makes sense. If I'm making a deposit or I'm investing every month for 10 years, that's 120 months. Minus 1 all over 0.045 over 12, all in square brackets. So this is complicated to enter all in one step. It's doable, but I would prefer to show you in person how to do that. Instead, we are going to go step by step. So take out your calculator and you're going to follow along with me. So, and I'm even going to maybe highlight here what we do. So step number 1, we're going to enter this right here, just this, first. So I put a little 1 here. So everyone, turn on your calculator, type exactly as you see it and as I say things. Open bracket. 1 plus 0.045. Now, depending on what you've become used to, either using the fraction button or the divide button, 12, close bracket to the exponent, 120. Hit equals. You should be looking at 1.56699, blah, blah, blah. Don't clear anything. Now we're going to subtract the 1 next. Okay, so this is next. There's number 2. So everyone now just don't clear anything off your calculator. Minus 1. Hit equals. 0.5699, blah, blah, blah. Now we're going to do this part. Number 3, the bottom. So we're going to hit divide, and we're going to do divided by 0.045 over 12. So again, don't clear anything off your calculator. Everyone's still looking at 0.56699. Divided by. If you want to, you can open up a bracket. That's maybe a smart thing to do. So open bracket, 0.045, then divided by 12 or ABC button 12, however you like to do your fractions. Close bracket, hit equals. You should be looking at 151, 198, blah, blah, blah. The last thing, we have to multiply by this 200. So there's step number 4. Don't clear your calculator. Times 200 equals. You should get 30,239. Now money, 2 decimal places, 61 cents, dollar sign. So we just walk that through step by step. If you didn't get that, you need to go back, listen to it again, step by step. $30,239.61. If you followed and you got that, awesome. Give yourself a huge pat on the back. Actually, we're going to say pat your tummy with your right hand and rub your head in a circular motion with your left hand. See if you can do it. Okay, so that's how much would you end up with. So there's our future value. The next part, how much interest did you make? We got to figure out how much money you put in yourself. Well, let's figure that out. How much money did you put in yourself? So we'll do this, our payments. Well, we put $200 a month in every month for a year for 10 years. That's times 120, right? 200 times 120 payments using our calculator. 200 times 120, 24,000. So we put 24,000 of our own money in. How do I figure out how much interest I made? Well, I walked away with just over 30 grand. If I subtract what I put in, which was 24,000, I get the amount of interest I earned, which was $6,239.61. And that is our interest earned. Not too bad. And for your test, again, this isn't going to show up on your 30% thingy. For your test, you should always show as much steps as possible. We just did it all in one. You don't have to show me the jump from the formula to the final answer. However, the danger, as always, if you make a quick calculation error, I can't see where you went wrong. Therefore, I can only give you one. This might be like a four-mark question. I can only give you 1 mark for the formula, and I can't trace through where you may have made a mistake. So it's risky. But if you're comfortable with your calculator skills, then by all means, I'm not going to deduct, or I'm not going to say how did you get this on your test, like I would normally. Number 2, if you invest $1,000 every third month at 3.1% compounded quarterly for 25 years, how much will it be worth at the end? So again, how do you differentiate an annuity from a normal interest question? You are investing or depositing a monetary amount, $1,000, on a regular interval every third month. So right off the bat, there's our R. Every third month, that's just a fancy way of saying quarterly, right? So quarterly, that's our C value, 25 years. Time, interest rate is 3.1. Sorry, I should have wrote a capital R there. And I told you actually I didn't like that for that exact reason, so I'll put PMT there. And our interest rate is 3.1%. How much is it worth at the end? Okay, future value. A equals, I'm putting $1,000 in every third month, okay. 1 plus, don't forget to convert the interest rate to a decimal. Compounded quarterly, so 0.03 divided by 0.031 divided by 4 to the CT. Okay, so we'll make that little side calculation here. C times T, which equals quarterly times 25 years, which is 100, minus 1 all over 0.031 over 4, all in square brackets. I'm going to walk us through the calculation again. If you don't want to listen to it and you want to test it, which I think is a good idea, test your skills without me walking you through, then pause it, come back. Entering it just like you see it, step at a time. Open bracket, 1 plus 0.031, close bracket. Oops. 0.031, ABC or divide button, 4. Close bracket, exponent button, 100 equals minus 1 equals divided by open bracket, 0.031, divider fraction button, 4, close bracket, equals times 1,000. You should have got 150,000. Hopefully you're nodding your head right now. $208.61. If you got that, you are a financial math genius. Number three is a very good multi-step thinking question. Thinking in the sense that you have to make a game plan. So, you put $100 a month right off the bat as soon as you see that annuity. In an account that pays 4.8% compounded monthly, after 4 years, the interest rate increases by 1%. How much would you have after 10 years? So there's really 3 different questions within one going on here. You'll see why in a second. So our game plan. We're only earning 4.8% from years 0 to 4. So there's step number 1. And it's an annuity. So we want to know how much that value is going to be worth. My payment, $100, 1 plus 0.048, monthly is 12. 12 times 4 is 48, minus 1 all over 0.048 over 12 in square brackets. I'm going to take the training wheels off. I'm not going to walk you through the calculation. Pause it, try it yourself, make sure you get what I get. So at the end of 4 years, you would have $5,280.16. Now, years 5 to 10, the interest rate changes. So it's almost like doing a question again, or a different, like part B of the question. And this would be years 5 to 10. Still making monthly payments, so we know it's an annuity. Everything stays the same except for the interest rate. So 100. 1 plus 0. Now it increased by 1%, so it's going to be 5.8. Still monthly. Years 5 to 10. Don't fall trap to this. Year 5, year 6, year 7, year 8, year 9, year 10. That is 6 years. Just using your fingers. 5, 6, 7, 8, 9, 10. 6 years. 6 times 12, 72 minus 1, all over 0.058 over 12. Square brackets. Again, make sure you try this on your own. You should get $8,587.15. So in the first 4 years, you earned just over $5,000. In the next 6, you earned just over $8,000. However, since the interest rate changed, that first kind of bank of money, the $5,280.16, that still accrues interest through years 5 to 10. It's just sitting there accruing interest, just like a normal compound value question, compound interest question. So part C, if you will, to this question is just a plain old compound interest. So we want to know how much money this $5,280.16, how much money that turns into sitting there accruing interest for 6 years. So at the end of year 4, that lump sum gets invested at the 5.8% monthly, and then again to 72. That's your formula from a couple lessons ago. That turns into $7,471.67. If I want to know the total value, I have this amount plus this amount. So my total value equals, adding those two numbers together, so we're going to add those, $16,058.82. Again, that's a good thinking multi-step financial question. This unit again is not going to be in your 30% final thingy, but a question like this may or may not show up in your seat work, maybe on your final test. We'll see. Example number 4, how much money must be invested every 6 months? You see every 6 months, that is a regular interval. You have to think annuity, and in fact, we're searching for the PMT here. So how much money must be invested every 6 months for 8 years to have 20,000 saved? Assuming you found an investment that paid 6.25% per annum, compounded semi-annually. How much interest was earned? So we are looking for the PMT. You were given the final amount, 20 grand. Technically speaking, you could use the present value annuity formula coming in the next lesson, but we can take care of it here too. We just won't be using the fancy formula. Instead, we're going to use a series of algebraic steps. Anyways, final amount. This is the more useful, just like present value of a normal compound interest question. People want to know how much they need to put away to have this much in the future. I want 20,000 in the future. I need to know my payment, 1 plus my R value, 0.0625, semi-annually is twice, 8 years, 2 times 8, 16, minus 1, all over 0.0625 divided by 2 in square brackets. We're going to go through the steps, walk you through, and at the end of the day, you're going to end up with a number beside a variable. Just like this is going to be like 2x, let's say. How do you solve for x? Or in this case, how do you solve for the PMT? You divide both sides by that. So what we're going to do is we're going to take 20 grand and we're going to divide by whatever we get here. So step by step, open bracket, 1 plus 0.0625, ABC or divide button. 2, close bracket, exponent button, 16 equals minus 1 equals divided by open bracket 0.0625 ABC or divide button 2 close bracket equals. Don't clear that. Now you need to type in 20,000 divided by the answer. So most of you should have an answer button on your calculator. So again, 20,000 divided by the answer button, and we get PMT equals $982.47. Now, that works out to be
United States dollars equals 1,197 Canadian dollars.
Now that works out to be how much you have to put away every 6 months. If you want to figure out how much interest was earned, you have to figure out how much of your own money you put in. How do I do that? Well, I made that payment every 6 months for 8 years. So in other words, I made that payment 16 times. So without clearing anything on your calculator, you could just type in right now times 16. We get $15,719.54. That's your own money. I need to figure out how much interest I earned. Well, I walked away with 20 grand minus how much of my own money I put in, which, while we're thinking about it, if that calculation I just did, how much my own money I put in, if it came out to more than 20 grand, that's a pretty good built-in self-check to tell you you made a mistake. If you're investing money and you put in more than you walked away, your investment lost. And yes, that's possible in real life, but for our purposes, we're basically assuming guaranteed interest. So that's a very good self-check. If you ended up with more, you messed up, probably. Don't just write that down. Go back, double check your work. Our interest, we earned $4,280.46 in interest. Not bad, right? I got one more kind of fun one for you. Fun in the sense that it might be eye-opening for some of you, especially if you have a job. So let's assume you're currently 16. And we'll just, for argument's sake, we're going to say on your 16th birthday. And you have a goal to retire at age 56. If you put $50 into an account every other, let's say every other week, not every over week. Fix that typo. Paying 3.6% compounded biweekly. How much money would you have when you're retired? How much interest was earned? Now I picked biweekly because most of you, if you have a job, get paid biweekly. So in other words, this is like the equivalent of if you put $50 away every paycheck, you are never too, just as a quick aside, you are never too young to start investing. You will thank yourself when you're 56. And no one says you have to just put $50 away. Once you get older and get better jobs, you can put more away if you want to, whatever you can afford to. Okay, so you're putting money into an account every other week. That's an annuity. We want to know how much you're going to have when you turn 56. So this is future value. You're putting $50 in. 1 plus my R value, 0.036. Biweekly is 26. Your exponent, now C times T, would be 26 times, now not 56, how many years pass between 56 and 16? 40. So 20, using our calculator, 26 times 40, we get 1,040 payments. Minus 1 all over 0.036 over 26 in square brackets. Let's do it step by step. Open bracket 1 plus 0.036 over 26, close bracket, exponent 10, 40, hit equals, minus 1, hit equals, divided by, open bracket, 0.036 over 26 equals, times 50. We get $116,151.17. Hopefully that's what you got. Hopefully I'm right. It's easy to make a mistake. Let's do a quick little self-check. How much interest was earned? Well, we want to figure out how much of our own money we put in. So we put in $50, 1,040 times. 50 times 1,040 equals $52,000. So over the course of 40 years, you put 52 grand in of your own money. But you walked away, so this was our own money. This was the future value. How much interest did we earn? Well, let's subtract 52,000 of our own money. If you do that, you realize that you over doubled your money. You earned $64,151.17 for free. Not bad. And not bad that when you retire at 56, you'll have a little nest egg there in addition to maybe any other savings you and your significant other might have, or any other investments or pensions that you might get in your full-time employment. There's your C work. That is it from me for recording lessons this quadmester. Again, you have one more that was previously recorded in a previous year. That's it. Swan song. If you're working on the bonus unit, remember your test is going to be on Tuesday. I think I have it starting between 10 10 or so in the morning. Make sure you double check that on D2L. And there will be 0 exceptions for missing that timeline and missing your solutions to be uploaded, which by the time you watch this, you've probably already received an email with that information. That's it. Once again, thank you for listening. All Quadmaster, thank you for trying your best, and best of luck. Happy mathing.